How old do I look? Well, my line. Oh, you're right. Never mind. I started straining the ice. Can you erase that?
out by his food and he likes hanging out by that toy. What's that all up in here?
Yikes.
Non-international, right?
I thought it was International May, but I'm not sure.
Oh.
International April, maybe. I don't
No, I think there's a different.
know. Okay.
Like there's.
That's okay.
I'll just leave it for now.
If you're on board, just let us know in the chat room that you're here. We'll start when we get a couple people. So maybe I think Isabella might be joining us. Oh, Margot, great, sweetheart. We'll wait just a minute to see. We're doing the, we received your test and we're mailing the results back to you. So today we're doing the polynomial packet, which is pretty involved. We want to do that before your next test, and the grammar 1 packet. So I'm glad you're here, hon. So if you just want to write this down, whenever you could take test 7 on page 692. Hi, Isabella. Glad you're here, hon. We're glad you found us. We found the alley behind your house, so it was easy to drop off your packet. So we're doing polynomials and grammar 1. So we'll get started in case, and then we'll see if Sophia jumps in. Okay, so this is pretty big math packet. About 80 points on the test will be on this. So I apologize early. We decided to put polynomials and quadratics together because they are sort of together. So we'll start off easy on page 1. So you can see these are all the polynomials by degree. When you add them, it's pretty easy. You just add the like terms. And when you subtract, the only tricky thing is to distribute the negative. And they might catch you on that. So if we try this first one, and then I'm going to give you a couple book ones to try. We'll do this one together. We have 4x plus 2. Then we're going to distribute this, so that's a minus 2x and plus 6. So that'll be 2x plus 8 is 10. Subtract the 8. 2x is 2, so x is 1. Thank you, College Board, for 10 points. Okay. So with the next one, I like to align them like this on the test. So we have an a squared b. We have a negative 3b squared plus 6ab squared. And like I said, these will probably be more at the beginning. We're going to try one in a minute. Then I have to distribute this negative to every term. So this will be a plus a squared b. And I'm going to put it right below it, negative 3ab squared, thank you, and plus 3b squared. And so when I add these are additive inverses. So I'm going to get 2a squared b plus 3ab squared, which is going to be c. Thank you, College Board, for 10 points. Okay, so I'm going to do this one and then give you a book one to try. So these are all nicely aligned for us. So we have 7x squared minus 9x minus 5, which will give us answer choice A. So I would like you to go to page 1124 in the blue book. One second and I'll tell you the problem. You'll probably beat me to it. Yeah, I'm going to have you do number 6 and just put your answer in the chat room when you've solved it. So this is just sort of at the beginning, a number 6, but it's not too bad because they've aligned it for us. We're starting off pretty easy with the merry-go-round going away around pretty slowly. So you can just put your answer in the chat room. There might be a little delay on this, but I'm glad both you girls are here. Yes, Isabella got it. It is A. Thank you, College Board, for 10 points, and Margot got it as well. Okay, so we're starting pretty slowly, but this is a difficult lesson. Let's look at this one. So again, we're going to align them. X cubed plus 3x plus 5. We want 2y, so we want 2 of everything. So always look at the prompt. And then below it, we'll have an x squared plus a 6x. That's why I like to align these. And then I can add them. And I will get 2x cubed plus an x squared. This one has no x squared, so that's why I left a space. And so this one, just a step up, will be C. Thank you, College Board, for 10 points. Okay, we're going to go on and try the next page. Now, this is how they often do it, and so I want you to get you ready for this. And this can sort of shorten your time. So here we have an expression, but look at the prompt. All they want is the one before B. They just want the one before X. So we know we have a 6X, and we can do minus 2 times a minus 2x, so that'll be 6x. I'm just doing this part. Plus 4x equals 10x. And so all I want is the 10. And I don't have to waste any time getting the x squared and the number. So if you see 5, just put C5 into the chat room. I'm just trying to show you that if you train yourself to look at the prompt, because probably a million juniors will do this whole thing, no problem with that, but all you're after is the coefficient before the x. So I'm just trying to shorten your time a little bit. So if you see 5, if you just put that in the chat room, because that's how they'll often express it. Thanks, Margot. And Isabella sees it. Isabella, what's your, what do they call that, Jim? What is that a picture of?
Maybe a bird.
We wondered if it was a bird in your, what do they call that?
Handle.
Icon, whatever's before your name there. Is it a bird? I'm just curious. Okay, now we're going to go multiplying. Okay, so when you multiply, I don't waste your time much. You're going to use the distributive property, remember, always. And then you guys know how to FOIL. That'll be first, outer, inner, last. Okay, so let's look at number 1. Which of the following is not equivalent to 8m squared? Well, this one will not be. Do you see it's 16m squared? So this one does. This is 8m squared. This one would be m square root of 4 times m square root of 4, which equals m squared times the square root of 16, which is 4m squared. So this one is a not, but this one is. So A and C don't work. It's a lookaburra. Oh, thank you, hon. Is that, I never did. Oh, it's a K? Okay. Kookaburra. Okay. Thank you. Okay, now if they give you one like these, the easiest thing to do is not try to factor this. This is one where you're going to use the choices. I've heard of those birds, kookaburra. I think it's in a kid's rhyme or lullaby or something. So look, if we took 4 to the 4th power, that would be way big. So A doesn't work. If I took 4 squared, that's 16. That doesn't work. 2 to the 4th, well, that's going to be 16. But let's try this one. 2x squared. And so the easiest way, if they give you one of these, is to look at the choices. So that'll be 4x squared, and then we're doing the inner and the outer. These are to the 4th, sorry. That's squared. So it is D. So one like this, don't try to factor this because it'll be too hard. It's easier to look at the choices. Okay, so another one. Okay. Again, we're just trying to get B. And so the B is the number before the X. So if we did this, we would obviously have multiplying 6x squared plus 12x plus 6x plus 6. 6x plus, 3. So we're just worrying about the coefficient before the x, which in this case would be 18. And hopefully that makes sense. Okay, it was some kind of rhyme like Kookaburra sits in the old oak tree. Now I'm really pulling out some brain cells from my childhood, hoping to make you smile. So here we have to go here. So we're going to have to FOIL this first. Then distribute a 2 over everything. That'll be 26x, which looks a lot like C. So one more, and then I'm going to give you a couple of very hard book problems, not to be mean. Okay, A, B, and C are constants. If the equation is true for all values of x, what is B? Well, let's FOIL, or let's distribute. So we're going to get 6x squared plus 18x plus 8x plus 6. So that'll be 6x squared plus 26x plus 6. So our B is going to be 26. Now, don't get mad at me because I'm doing some book problems. So the first one I want to go to is, and I'm taking you into the deep water. Whoops. Can't clear this. Hold on. There we go. Okay, I guess I'll use blue. So I'd like to try page 1135 and expect a hard one. Hold on. Oh, my book is so beat up. I can't wait till 2020 is over. 1135. Okay, we're going to try number 33. So it is very hard because it's in the grid ends. So we have negative 3x squared plus 5x minus 2. I would just distribute that minus 2 to everything and align them. Notice that all we need is the number before the x. So can you get the number before the x? It should be an integer. It is pretty hard. So all you're trying to do is get the number before the s. And take a stab at it. So we make all our mistakes here. But I like to always align the variables because then it's easier to see. Anybody have a guess? I sort of started it here. You're just trying to get the b, the number before the x. So aligning and distributing the -2, does anybody see what b would be? Yes! Isabella nailed it. It is 9. Thank you, College Board, for 10 points. Pat yourself on the back there, and Margot got it too. So everybody pat themselves on the back. Okay, now you've got a really hard one there, but we're going to go to an even harder one. Not because I'm a mean person, but... So we're going to page 732, and we're doing number 20. And I think you can, let me see if you can use a calculator on this one. No. Okay, so this one, so I'm not being mean by taking you to the hardest one. I just want you on test day to have confidence to try them all. So I'm going to distribute this 10. And then the 10 to this. Okay, so I need to find a plus b. So this time they're asking for this number when we add up the coefficient before the y, which will be a, and we're going to add this number, which will be our b. Like I said, I didn't do this to be extremely difficult. I want you to have the confidence to try the hardest one. I think the hardest thing about some of this math is just getting used to how they present it, and that's why we do the book problems. Because initially, you might be intimidated by this. if you're confused, which is very understandable because this is the hardest one, just tell me why you're confused. Margot nailed it. Yay. Okay, so our this will be 200 because I'm just adding up these coefficients. This is 6432. Whoops, that's a 200. It didn't show very well. That's a 4, sorry. So we will have 6432 and a 200, which will give us 6632. Oh, Sophia, no problem, hon. So you can watch the beginning a little bit later. We saved it online, and so we're trying a real hard polynomial problem, Sophia, in the book. So it might be confusing. It's okay. I'm glad you told me you're here. So let's see. Isabella, do you see that it's 6632? That I just added the number before the y and to this number, and I got 66 or 64. Sorry, wait. I got 6632. Oh, good. Yay, Isabella. Okay, wait. Okay, we're good. All right, so Sophia, we're back in the packet, so I know that was probably confusing. So we're on to page, let's see what number this is. 6, I think, in the packet. So you missed the part where we are always doing the easy part to get you on board, so you can rewatch that. Okay, this is a difficult one. This would be in the hard zone. I think there was one like this on your test. So this A is a trap, and I'm going to show you why it's a trap. So what we're going to do is just FOIL this, and they give us 12x squared. Now they tell us A plus B is 7, but then do you see, we know this, that A times B is 12, because when we FOIL it, it's going to be A times B equals 12, 12. So we know A times B is 12, A plus B is 7. So that means the only A's and B's that would work are 3 and 4, or 4 and 3. We don't know which is A and which is B. And I apologize, Sophia, that, by the way, Sophia, we did get your test, and we're mailing the results back to you. You should get them like beginning of the week. And nobody will see them. They'll be in a folder. Okay, so this was a trap because they wanted us to say, thank God we're done. But we have to put back in the 3 and the 4 and try this. Because we want the C, we want the number before the X. So if we try this, we'll get 12x squared plus 12x plus 18x plus 18. 12 and 18 is 30, so it's beginning to look a lot like this. So then if we do it the other way, in other words, what I'm going to do now is put 4 in for A and 3 in for B, then I'm going to get 12x squared plus 9x plus 24x plus 18. Do you see 9 and 24 will give me 33? So this very hard one will be D. So if you see 6, put that in the chat room, girls, and if you don't see it, just put a question mark. We're going to try a book problem just like this. I think it was on your test. So I'm just waiting to see if you see 6. It's way hard. I think this might have been on your test. I'm not sure. Let me check. We're going to do the one in the book together, so by 2 of these. Okay, so Sophia's good, and okay, so Margot's confused. But that's fine, sweetheart. So what I'm going to do is we're going to go to a book one and do it again. Okay, so you'll see it this time, I pretty much think. We're going to go to 1232. It is a hard one. Number 15. And don't worry, Margot, I'm not going to leave until you see it. Oh yes, it's the hardest one. And I think this was on your test. Maybe not. No, maybe not. Okay, so let me do this slowly, Margot, so you see it. It's the hardest one. So we have ax plus 2 bx plus 7 equals 15x squared plus cx plus 14. Okay, and so they tell me that a plus b is 8. So a times b is going to give me 15. Okay, I hope that's okay so far. So Margot, is that okay so far? A plus b is 8, 8 times b is 15. So the only two numbers that would work would be 3 and 5, and they want you to go for A. It's a trap. So I just want to know, this is for Margot. Is this clear at this point? Just say, okay so far. I know it's a very hard one. Okay, great. Thank you, sweetheart. So now I'm going to put in the 3 and the 5. 3x, and you other two girls can just try this. So I'm going to FOIL it. So that would be 31x, which is starting to look like D. And if I do it the other way with a 5 at the beginning, and this is the hardest one, like only 6% of the kids would get this right. But like I said, my job is to sort of demystify this test, so it's not too bad. So 6 and 35 will be 41. So 31 and 41 will be D. Okay, so for Margot, does that help? Do you see 15 now, which is the hardest one on this particular test? And I'll just wait for you and the other girls to just tell me, I see 15. It's the same thing. It's just they put it in a mess so that you would be very daunted and not even try it. or get trapped into picking A. So just put C15 in if you see it. And I apologize ahead of time that this math lesson is so long. But I couldn't separate. So Margot, great. I know I took math classes and I often didn't understand the teacher, so I get it. And is Sophia okay with 15? I have 3 math princesses out there. So Sophia, is this okay? Great. It's just like we're around a coffee table, except I can't see you. Okay, this one is hard. So I'm going to distribute the 2. My job is to get K. It looks like impossible. So I have 2x squared plus 16x plus 12 minus 4x plus 4k. Okay, it's all divisible by x. So I can divide this by x, this by x, and this by x. And so these numbers will all go away. But I have a remaining 12 plus a 4k that aren't going away. So we're going to try to get those to 0. Subtract 4k. So divide by minus 4. K is going to be a -3. This was a hard page. So if you see 7, sort of, we're just trying to get whatever is not divisible by x out of the way. I doubt they would give you one this hard, but in case they do, you'll be armed and ready. So I just need a C7 around the coffee table. Wish we had a coffee table and some cookies and some coffee or tea. So I just need a C7. I sound like a bingo game, I know. Or a question mark. And I know we're going to Mount Lebanon, to Phoenicia, to Graham Street, where my husband's great uncle lived. Okay, Margot sees it, great. And so does Isabella, great. I know, so all we're doing, thank you, Sophia, we're trying to demystify the hardest test you've taken ever in your life to this date, I know. So this one, if I put in a 4, I get out a -3. What's true? This one I didn't see at first, but the thing is, the answer is D. So if I put in 4, the expression has to be x minus 4. And then there'll be a -3 left over. So this is a little confusing. So let's go to a book one. Let's try. Sometimes if I give you a book one to reinforce it, it makes better sense. This one didn't make sense to me at first. So we're going to 1247, number 29. I really don't expect you to get it so far. I think my 2020 book has had it. $12.47, number 29. So it says for a polynomial If I put 3 in, what's left over is a minus 2. So what that basically means is the expression has to be x minus 3, and this is what's left over. So it's just D. Even if you can't see it, like you can't understand the process of it, don't worry about it. I would just say the answer is going to be D. And to help with this process of seeing it, we'll do the last one on this page. We've already conquered 6 pages. Okay, so I'm just going to distribute this. This will be 2x cubed minus x squared. So the prompt is to give me A, B, M, and N. I don't have any A or B, but I do have an M because that comes before the x squared. My M is a minus 1. My N is 2. And 2 plus a minus 1 will just give me 1. So take a minute. I just wanted to stretch your brain again by sort of, because I don't think you got necessarily problems like this in your math class. And so our last thing is to do a polynomial long division. So I sort of want to base this here. Have you had this in your math class or not? Just write had this, did not have. Because that'll sort of help me help you if you've seen this before. I don't know if you had this, because there'd be 3 different districts here, obviously. 3 different math teachers. I sort of want to know, oh, so Margot's had this. Let me ask Sophia and Isabella, have you ever seen this before? If you haven't, we did one at the orientation, in the orientation class, and it's not that difficult. Okay, so Sophia did not have this, so we want to go very slowly through it for her. And what about Isabella? Have you ever seen this dividing a polynomial? Okay, and Isabella did not have it either. So let's look at this first. So if I have 6 and I divide it by 4, long division back in grade school, I will have, it goes 1 time, that's a curvy 1. 1 times 4 is 4, and so the remainder would be 2, and then I put it back up over the 4. So that's how I do it with numbers. So, and it would be, this would definitely be an end zone problem, so not to worry too much. So if I have 2x squared plus 6x plus 3. Could I pick a number? Yes. I'm dividing it by x plus 3. Okay. So based on our long division from grade school, x would go into x squared 2x times. So 2x times x would give me 2x squared. 2x times 3 would give me plus 6x. Then I have to subtract what comes next. And so I parentheses protect that. These will go away and I'll have a 3 left. And so the remainder is what I'm after. It would just be 3. Okay, so I realize it's probably difficult so far. We're going to try one in the book. And I know for Isabella and Sophia, you haven't had it yet, but that's not a problem. So I like to go to 729. You can see it's a hard one. It's number 13. I just don't want you to see it on the test and have shell shock or something, because you can have a great life and not solve this. I promise you. Do you see it's a number 13 anyway? And I'm going to go through it very slow because 2 of you have never seen this before. Whoops. And why I did this, again, if we had 4 into 6, I would say it goes 1 time, and then the remainder would go up above the divisor. So if you haven't seen it, just stay with me. I'll go through very slowly. It's the same thing as long division, except that we have variables. And we could pick a number and see what comes out, obviously. Okay, so x goes into x squared just x times, because x times x will be x squared minus 3x. And they only make these, they don't make, even though this is a number 13, it's not that difficult. So now I have to subtract this like I had to subtract this here. So I put a subtract and I parentheses protected. So that will give me, when I distribute it, I'll get a minus and a plus. So the x squares will go away. A -2 and a plus 1x will give me plus x minus 5. Okay, so now x goes into x just 1 time. X minus 3. And just because they said they could put this on the test is why I'm bothering you with it. So I have to subtract it like I did here. So I distribute the negative. The x's go away and I get a -2 over x minus 3, which is answer's choice D. Okay, so for Margot, if you see 13, you could tell me. Isabella and Sophia, just write sort of if you sort of get it, because I'm going to do one more. Because I apologize that you didn't have this in math and I'm your first person to see it. You can see it's in the hard zone. So all I need is a sort of. Okay, thank you, girls. Let's do one more. And then we'll put this to bed. So we're going to go to page 860, number 12. And like I said, I'm not doing this to be mean. I'm just doing this because they can put it on the test on page 860. It's a number 12, so you know it's a hard one. But at least you would have a clue rather than no clue at all. Margot, you can go ahead and try this one and put your answer in the chat room, because you've had this. Okay, so I'm going to sort of go through it slowly. So, again, we're going on the basis of our long division in grade school. Wouldn't it be nice to go back there? But remember, when you were in that age, things were hard, too. So that should be... Anyway... And Margot, when you get your answer, just put it in the chat room. So 4x goes into 4x squared, just x. So then we multiply 4x squared plus 2x. Then I'm going to subtract everything. So that'll be a minus. This will be a minus. And I'll get 4x. And so 4x goes into 4x just one time. Here's the tricky part. I have to subtract it all, so I parentheses protect it. And my remainder will be a -2. Which would be answer choice D. And so I'm sorry I have to be the one to sort of explain this to you. So if you could, let's do it this way. If you could try it. Now, if you saw one, that's all I care about. I mean, I'm just trying to make it so that on test day it doesn't look like a complete confusion to you. So just write down, I could try 12 or a big question mark, like I wouldn't know what to do. I'm just trying to give you exposure to everything you might see. And it's sort of not fair that they might put this in the hard zone and you would never have seen it. Okay, so Isabella could try it. That's all I care, sweetheart, is that it wouldn't look like a foreign, like Einstein to you, you know? Oh, so Sophia could try it too. That's great. That's all I wanted to do, is give you a bench that you could sit on and at least try it. Okay, so we're going to go to page 8 in the packet and skip those two. So I know, Margot, you're pretty good with these. So we're going to try 3 and 4 on the next page. Okay. Same thing. Again, that's why a strategy class that's 3 hours can't help you as much as going through all this. So x goes into 2x squared. That would be 2x times. They gave us the remainder and they want us to get the dividend. So this one's a little different. So 2x times x minus 1 would be 2x squared minus 2x. Again, I'm subtracting this whole thing. So that would be 2x. It would go in plus 2. So that would be 2x minus 2. So my remainder is 2 over x minus 1. And I have to get the a, which would just be 2x plus 2. Okay, so if everybody sees 3, just put it in the chat room. I could pick a number. While I'm waiting for you, I'm going to try to pick a number and just see if it works. Let's say x is, I want to make it reasonable. Okay, so Isabella sees it, Margot sees it. Oh, good. I'm just waiting for Sophia to see 3. Maybe I won't try a number. Okay, Sophia sees it. Good. Okay, now this one might have been on your test, and it looks horrible. but it's not. So again, we're putting on our demystifying glasses to get to where we need to in life. We're dividing by ax minus 2. So all I'm doing, they made this seem impossible. So I am saying a goes into 27 and we get out a minus 9. So basically, all I'm doing is I'm doing minus 9 times a is 27. So pretty easy. A is going to be a negative 3. I'm pretty sure this one was on your test. So all we have to do is just focus on the front end of the problem. Trying to get a red here. Well, yeah, there it is. So A goes into 27, just negative 9. They're hoping to flip you all out up with all this other stuff. So let's try a book problem that was on your test that you might have not seen at the time. Okay, so I'll try, oh wow, sorry. I'll try doing this in green. So we want to go to page 1118, number 13. I think this was on your test. Okay. So, horrible problem. We have 24x squared plus 25x minus 47. We're dividing this by ax minus 2. And you might say to yourself, are you kidding me? How do I do this? This number would be a negative 8x squared. So basically, I don't care about this part of the problem. Oh, I got Christmas colors. I'm trying to say a negative 8 times what number A would give me 24. I'm sorry, negative 8 times A. So the only number that would work would be a minus 3B. And you could really do that in 10 seconds. You're just looking at this, goes into this, how many times. They're trying to mess you up with all this other stuff. And so when you get to the last, I would do the easy problems are at the beginning. When you get to the last 5, what I would do is scan them and say, oh, I know how to do that problem. I can do that problem. I can do that problem. So all I need is a C13 from you girls. And I wish I could send you warm cookies around the dining room table, but I can't. So I just want to, can you just say I see 13 or I don't see 13? I just took you into deep water. So Margot sees it. I think this was on your test. Yes, this was on your test. And those results are coming back to you for Margot and Sophia. And all you have to do is just look at the explanation in the back of test 3 and you'll know, hopefully that'll help you with what you missed. So I'm just waiting for Isabella. Okay, so Sophia sees it. Isabella, do you see it? Put an honest question mark if you don't. That's okay. We're just doing -8 times something equals 24. And so it has to be a -3. Hopefully I didn't lose my kookaburra. I know she has some siblings, so I hope that doesn't. I'll give her 30 more seconds. So Isabella, do you see 13? Oh, great. Okay, sorry, sweetheart. Okay, so now we're going on to factoring. Okay, so factoring, when you distribute, the postman takes the mail to every house. And when you factor, you take back what's in both of them and you just bring it out front. Okay, and this will be at the end of the test, most likely, not in the beginning for sure. So let's try this one. It's on, the answer's on the next page. So I wrote all this out and I saw that I could factor out an A, a B, and a C out of everything. And so then I bring it out front, and so answer A is correct. So let's go through this one. We have 3xy. 6 is 2 times 3yy. I can take a 3 out of both and a y out of both. That will give me 3y, x plus 2, which is answer choice A. I like to do this way of factoring because I can, if I circle everything, I can account for it. Okay, so let's look at this one. So if I have AAB minus ABB, what can I factor out? Both of them have an A, both of them have a B. Bring them out front, and I'm left with A minus B. And I got a little clue because look, AB is 8, A minus B is 2, so 8 times 2 is 16. Thank you, College Board, for 10 points. So if you see 2, just put that in the chat room so I don't know I haven't left anybody behind. I don't want to leave any math princesses behind. So our goal is to give you at least 30 points a packet. This one much more because this is all over the test. Okay, so Sophia sees 2. Thank you, sweetheart. Or at least Isabella sees it and Margot sees it. Okay, great. Now this is something that I'm sure you've all had this, the difference of 2 squares. And you have to know this on the test. So A squared minus B squared. This is just, you're bringing this up to the forefront of your brain for test day. This is A plus B and A minus B, because if I FOIL it, these 2 will cancel each other out. So basically I just take the square root of the first one, the square root of the second one, one's x, one's x, plus one's x minus x. Okay, so this one isn't too bad. So if x squared minus 9 is 0, what is x? Not so bad. I could factor this x minus 3, x plus 3. Then I know I set each of these equal to 0. X could be a 3, or x could be a minus 3. And you could just say, Mrs. Hessler, this is so easy. X squared is 9 and x has to be 0. It has to be a 3. So I'm sure that one probably is okay. We're going to try some book ones in a minute. Let's look at this one. This one's hard, first of all, because you can't see it. So really, it's x a squared over xb squared equals x to the 10th. And so I have a little clue because I have a plus b is 2. So I'm trying to get a minus b. So that should trigger my brain. I need the difference of 2 squares. So if I try this, remember with exponents, we're going to subtract them. So this is a squared. So basically, I'll have a squared minus b squared is 10. That one's a little bit hard to see, but we just subtract the exponents. Well, I know that factors into a minus b and a plus b. I know that a plus b is 2. So 2 times what number will give me 10? It has to be 5. So just let me know you see 2. Again, another number 2. Again, it's just something you need to know, the difference of 2 squares. And once you know to look for it, it's not so bad. So I'm just waiting for a C2. Again, bingo. Sorry. So the grammar lesson today isn't so bad. So we tried it, but it's important. It's on where to put commas, semicolons, colons, and what else? Commas, semicolons, colons, and em dashes. Okay, so this is running into the last one, but I think Isabella sees it. Sophia sees it, and I'm just waiting for Margot. And so your first test scores, that'll be your hardest grade, sweetheart. Okay, so let's go to this one. So what I could do first is factor out a 9, and that'll give me 9a squared minus b squared. And I say, oh, I know this guy, that's 3a minus b, 3a plus b. That has to be d. No, I'm sorry. That has to be B. Okay. Before we go to some book ones, I'm just going to take the square root of this, the square root of this. That'll be 4x minus 2/3, 4x plus 2/3. And that has to be C. Okay, so we're going to go to some hard ones in the book. And you're like, Mrs. Hessler, give us a break. But I want my math princesses to shine on test day. So we're going to go to a hard one, 339. And this was on a real test. Number 20. If it's a number 20, you know it's got to be hard, but it's not. And like I said, what I would do is I do the first 10 and then I look at the last 5 and see what looks familiar to me. What can I do? Because we did number 19 and it was very easy. You don't know, for you, 20 might be easy and 17 might be hard. So we know u minus 2 is 2. So we're just going to put this in for this. Then this looks like the difference of two squares, u minus t and u plus t. This is the thing that most juniors wouldn't spot. So u plus t is a 5, u minus t is a 2. So pretty easy. 2 times 2 times 5 would be 20, and that's what I would grid in. So if you see 20, let me know. Take a minute. I know I went through it pretty fast. I don't mean to do that. Just put an answer in the chat room if you see 20. We're going to have a break a little bit early today because before we do the quadratics. So I'm looking for a C20. It does sound like a bingo game. But that's the hardest one. Okay, so Margot sees it. But if you didn't know to look for this difference of two squares, they do give you a little clue here. But you might be blocked by solving it. So Isabella sees it. Great. Thank you, girls. And we're just waiting for Sophia. So we just have to bust this down into plus and minus. Oh, Sophia sees it. Great. So that's amazing. You got the hardest one. We're going to try another hard one. We're going to go to page 1010 and try number 30. You're saying, Mrs. Hessler, that's the hardest one again. What are you doing to me? Because this is a 30. Okay, so we know what to do here. We're going to take, it's the difference of two squares again. So this and this, so that'll be x minus the square root of a and x plus the square root of a, which looks like b. Now they wanted to trap you into picking a. It was an a trap. But look, if we try a, whoops, what am I going to get? I'm going to get x squared plus ax minus ax minus a squared. And I don't want that. I want just a. Do you see how a is a trap? Because if you foiled it backwards, you get an a squared at the end, and you don't want that. You want an a. So, again, if you see 30, just put it in the chat room. Put a question mark if you don't get it. They wanted to trick you into picking A because when you do the inner and the outer ones, oh, so I have C30s coming in. Yay! See, you're an expert now on the difference of two squares. So just a little more before our break. So let's go to the next page. Or no, we're going in the packet to factoring by grouping. So this is a little hard. Again, we're over preparing you, if anything. And you'll see a nice, so Sophia, the next, on Tuesday, we're going to be starting circles. we're doing 2 lessons on circles, and for Isabella that'll be Wednesday night, and then the next weekend is triangles. But we'd like you, Sophia and Margot, to take test 7, which is on page 692. At any point, maybe wait to see you get these scores back, which are going to come very quickly, and then you can try test the second test. Okay, factoring by grouping. Do you remember this a little bit? You just divide it, and you can factor out an x squared from each of them. It's really horribly hard. So let's look at this guy. I'm just going to pick numbers because I know I'll do it both ways. But remember, on the test, I'll make the doors up and down this time. You have a math door, but if you can't crack it, you can go in the strategy door because the College Board isn't going to ask you what to fill in. So here, let's just say x is 2, y is 3, because I know I might mess this up. So 6 minus 2 times 2 minus 3 times 3 plus 2 times 3 is 6. So basically I get 6 minus 4 minus 9 plus 6. So that's going to be 12 minus 13, which gives me a -1. So I want to get a -1 out of this. I'm just going to, when I pick these numbers, I'm going to go through the math door too, not to worry. So let's try putting in 2 and 3. A would be 5 times 5, no way, right? B would be 3 minus 2, which is 1 times a -1. It works. So B works. Thank you, College Board, for 10 points. To factor it, and I'll show you this mess, going through the math door. But if picking numbers works on one like this, why not do it on test day? No one's going to come out and ask you. So what I would have to do is factor out a 3 here. If I did the math doorway, that would give me, oh no, a 2. What am I smoking here? So I'm going to divide it up. 2, that'll give me 3 minus x. Then, this is the tricky part. I have to figure out, I have to get an x minus 3, so I have to factor out a minus y. And then I will indeed get 3 minus x, 2 minus y, which is b. But you might say, that's going to strain my brain too much and I get anxious during the test. It's okay to pick a number. It can get you 50 more points on the test. Okay, let's try this one. So there's a reason I did this one. So what we're going to do, I'm sorry, this is a math involved lesson. So we're going to take out an x squared from this part. That'll give me x minus 6 plus 2x minus 6. So this is where we're going to fly like an eagle above the problem. So just stay with me a minute. What value would make this whole thing go to 0? Do you see that if I put 6 in here, this will go to 0, and this whole thing will go to 0. And if I put 6 in here, this will go to 0. So what I'm saying is that if x is 6, the whole thing will go to 0. So if you see 2, just put that in the chat room. Basically, I just want you to see, if you fly like a bird above the problem, what would make the whole thing go to 0, and it would be a 6. And we'll just wait for C2s to come in. Thank you, Isabella. Thank you, Margot. They might do something like this and say what would make it undefined, and 0 in the denominator would do it. And Sophia sees it too. Great. Okay, let's go to this one. Well, let's try the picking the number door first. So let's say x is 1. And this is not cheating. This would just be a minus 1 squared minus a minus 1. So that would be a minus 1 plus, or no, it'd be 1 because minus 1 squared plus 1, which would give me 2. So I just need to get a 2 out of this. So let's put 1 in here. No, that's a minus 1. That doesn't work. This doesn't work. 1 in here doesn't work. Let's try this one. This gives me a minus 2. This gives me a minus 1. That's our answer. And that was maybe faster. Factoring, I'll show you, the factoring isn't that hard. So what we're going to do factoring, we have 3x minus 4. 3x minus 4 minus. So if I pull out a 3x minus 4, that would give me a 3x minus 4 here and a minus 1 to hold the place. So even factoring, I will get out D. But if picking numbers is easier for you, go ahead and try it. Okay? And so we just have a little more for our break, before our break. Again, I couldn't take polynomials and quadratics and split them, but it turns into a massive math lesson. So anyway, this is probably your hardest math lesson. Because I wanted to do it on the weekend and not on school night. So here, you probably had some of this on the keystones. I can factor a 2 out of that a 2x out of the numerator. Whoops. And then as we finish the example, that cancels and you're left with 2x. So let's try another one here. These kind, we have to backwards FOIL. So let's try this. What two numbers multiplied together give me negative 28? And it'd be a 7 and a 4. And so the 7 will be the negative and the 4 will be the positive. Downstairs, I'm going to get an x minus 7 and an x minus 2. The x minus 7s have it, and so this will be answer choice A. Okay. And there was a meaning for all these questions. Oh, this looks like the difference is 2 squares that we had earlier. So up here we're going to put the x minus 3's cancel, and we're going to get answer choice A. Thank you, College Board. Oh, this is what I was referring to earlier. What makes it undefined? If the denominator is 0. Then remember, we can't have something like that. So what number could I fly like an eagle and put in here that would trigger this whole thing to 0? If you see this, put that number in the chat room. What number can I put in for x that would trigger the whole denominator to go to 0? And I'm just going to wait for you girls to put it in. So what number can I put in here that would trigger the whole thing? If I put in a 4, it's not going to go to 0. But what number do I put in here that would make this whole thing go to 0? Margot, Isabella, yay! So if I put in a 3, yes, that's going to go to 0, and that's going to go to 0. Hallelujah. Let's see if Sophia sees it. So it's sort of like that flying like an eagle above the problem. And Sophia sees it. Great. Okay, let's try one more. We're almost ready for the break. I keep saying that, but okay. So they don't have, we can't put 3 in because that would make the denominator equal to 0. So we can do 2 things. Let's pick a number. Let's try x is, why not x is 1? So in the new, we'll have -1, -6 plus 27. This is just the pick the number strategy. I'm going to do the math in just a second. But that would give me 20 over 3 minus 1, which is 2. So I need to get 10 out of the answer choices when x is 1. Pretty easy. It has to be D. Okay. So now that's the pick the number strategy. If I was going to go through the math door, I would multiply this top and bottom by a -1. That would give me x squared plus 6x minus 27 over x minus 3. Because this is just multiplying by 1, so it's totally legal to do that. That would give me x plus 9, x minus 3 over x minus 3. So that would also give me D. And you can pick either strategy for test day. Okay, so before we go on, if you see 4, just tell me I see 4. And it doesn't matter which way you do it. Thanks, Margot. Again, if the pick the number works better for you or faster, Sophia, great. Okay. Isabella, great. Has anybody ever heard of that rhyme? Kookaburra sits on the old oak tree. I know. If I had boys in here, I would never sing that. Just saying. Okay, if you've heard that little rhyme, just let me know. I'm trying to put a personal touch to this because Isabella's handle is a kookaburra. I don't know what Sophia's is. Sophia, what's your, I don't know what they call that, the thing in the circle. I can't make it out real well. I don't know if it's, just tell me what it's a picture of. Okay, so anyway, we're almost done with this hard math before we go into quadratics. So what do you do if you get a hard one like this? Okay, I do not have common denominators. So I have 1 over so I have to get a common denominator here. It's going to be x plus 3, x plus 4. Could I pick numbers? Sure. But if I multiply the denominator by x plus 4. Oh, thank you, Sophia. I saw some girls getting their hair done for homecoming in the hairdresser today. And I guess one girl decided not to go to homecoming. She and her friends were getting all dressed up with their hair all fancy and went to go bowling because they were just saying, you know. So if I multiply this by x plus 4, I multiply this one by x plus 4. I know it seems weird to go to bowling in a gown, but they were going to do that. And then this will be x plus 3. So then we're going to do a book one like this. So then what I would do is I'd add these up. And the denominator would be x squared plus 7x plus 12. And then my last step, since this is all over 1, I have to flip it. And so this really hard one will be D. And not to worry if you're, I can't really make out your friends in that little thing though, Sophia. But anyway, we're going to do a book one like this, and I promise a break is coming. And again, I'm not doing this to be mean. I'm just doing this to, so we're going to go to page 14, or no, page 1232, number 13. I don't know. I don't think this was on your test, but 1232. I would sometimes like to do ones from your test, but I want to do problems like you'll see on test day, so that when you're taking the test, remember not to leave any blank. So we're doing number 13. Okay, so we'll go very slowly. X is bigger than 3 because we don't want to have 0 in the denominator. So basically we have 1 over x plus 2 plus 1 over x plus 3. And we can't combine these like we could unless we multiply by a common denominator. And this is a hard one. You can have a great life and not solve this. So we have to multiply the top by x plus 3, this top by x plus 2. So that's going to give me 1 over 2x plus 5, and then I'll just FOIL this. I hope I'm not going too fast. And the last step, because I'm dividing, and I didn't explain this much before, but if I have 1 divided by a half, say, I have to flip the fraction and multiply it. So for example, if I have a whole pie, how many halves do I have in it? I have 2. So I have to flip this finally, and I will get answer choice B. Could I have picked a number? I'm sure I could have. And that was a hard one. It was a 13. But like I said, I'm not doing that to be mean. I'm just doing it to stretch you so that on test day everything looks familiar. So if you see 13, if you could just put that in the chat room, that would be great. Thanks, Margot. I can't believe that girl was getting all dressed up to go bowling. I think they were just doing we boycott homecoming. Isabella sees it. Great. We only have one more page for break. Oh, Sophia sees it. Good. Okay, the next page. I'm going to go down to question 1 in the packet and see when we get down to quadratics, I'm going to give you a break because it's too much for one lesson. So let's look at this. If they make it an equation, all I have to do here, do you see the denominators are equal? So I'm just going to multiply this by x minus 2. So I will get 4x plus 3. Notice I have to distribute this minus sign. So that then was give me 4x minus 2x will give me 2x plus 6. So I can subtract the 2x, add the 6, and I will get x is 12. Thank you, College Board, for 10 points. So it's the same thing we were doing about getting the denominators the same. And our last one before we take a break. So we have a squared minus 1, which will be a minus 1 and a plus 1. Because I know that's the difference of 2 squares. That's something else that you have embedded in your brain from today. So that means I have to multiply this guy by a plus 1. And I have to multiply this one by a minus 1. And that's going to be 7. And now do you see what's happening? These will all cancel, the denominators. And so I'm left with adding up the numerators. 2a, oh, I forgot the 4, sorry. Plus 4a minus 4 is 7. So that would give me, oh, that's just an a. I don't know what I was doing there. This will just be a plus 1. So that'll give me 5a minus 3 is 7. 5a is 10, so a is 2. Thank you, College Board, for 10 points. Okay, so that's good. So now it's been an hour and a half of math fun. And how about if we come back at, let me just see here. How about if I give you an 8-minute break? So let's come back. You can use the restroom, get a snack. Let's see, 8, 4, can't even add, 4:33. No, 4:43, sorry. Mrs. Hessler. And this is what I was thinking of this ahead of time. As you get your snack, think about God knows the quadratic formula because he made rainbows. That's my happy break thought. So take a break, get something to drink, snack, restroom. If anybody stops you, tell them God knows the quadratic formula because he made rainbows. We're on a break.
You're having a break?
Mm-hmm.
You make too much noises.
He needs some food, Mike.
I gave him food.
Well,
Okay. Supposed to say things, Mike.
thanks, Mike. I said back at 4:43. I hope they don't wait an hour to come back.
It's pretty fun.
No, it wasn't funny. It is 3:43, right?
Yeah.
So if anybody's back, just let me know. I was so excited about my rainbow. that I wrote the wrong time. So I hope I didn't lose any of you. Oh, thanks, Isabella. Yeah, I wrote 443 and I was like, yikes. But I was really excited about my rainbow. And thanks, Margot. So we'll wait for Sophia. I couldn't believe that girl was getting her hair done and going bowling in a gown. I think just because they were boycotting homecoming. I don't know, weird, but I think it would be hard to bowl in a gown, but I don't know. So we'll just, oh, so everybody's back. Yay, I put the wrong time there, girls. Sorry. I was just excited about my rainbows. So we're in the packet on quadratic equations. It's our last thing to conquer. You can give this packet to your parents and say, look what I did. The grammar isn't that bad today, but it's key because it tells you where to put semicolons, colons, commas, and em dashes. So that's what, and dangling participles too. So quadratics go x squared. Obviously, when it's a happy day, it's y equals x squared. When it's like the rainbow, it's negative x squared because you need an umbrella. Okay, so here's standard form, which you're going to need for the quadratic formula. Here's intercept form, where they break it up so right away you can see the x-intercepts. So let's go to page 337, number 13. That looks like a hard one, but let's see. It's our last thing to conquer today, but it was a pretty involved math lesson. My goal is to give everybody 100 points at least in math. And 337, we're doing number 13, which is a hard one. So it says in the xy plane, the graph of the function, here I'll just put this on a whiteboard. I'll get rid of my pretty rainbows. Okay, we have f of x, and I'll get out of my rainbow mode. It's hard to see. Okay, we have two x-intercepts. Well, we don't have to bring out the big gun quadratic formula for this. We just factor it. X plus 4, x plus 1. This is a number 13 though. So it's hard. I'm not messing around. And like I said, we're going to start geometry this week. So that'll be, our two answers will be x equals a negative 4 and x equals a minus 1. So on the grid, the difference between a minus 1 and a minus 4 would be C, 3 units. So if you see 13, just let me know. Thanks, Margot. Isabella, great. So this is one you can just get the x-intercepts pretty easy. Oh, great. Okay, now the next thing is a little trickier. They do not give you this form, the intercept form. But here's what it is. Or it's also, I'm sorry, this is the vertex form. What was I saying? So if it comes in this form, you could write this down because they do not give you this formula. on test day. Remember I said there's a whole bunch of formulas they don't give you on test day. 8, not a whole bunch, 8. And so we're going to go through these. So the HK is your vertex. So I want to try a couple book ones with this. So let's go, to 346, number 19. Again, I think it's a hard one, but the best way is just to dive in, right? It is hard because it's at the end zone. So we have, and I want to get what's true about the parabola. Well, let's look at it. It's a negative, so that means it's like the rainbow. I just like to draw rainbows. I have a problem. Okay, and then according to the formula, it'll be x minus h squared plus k. So 3a is our max. So it'll be up here because it's a negative. Oops. And so 3a, just out of the formula, it would be 3h. So 3a is our max. So if you see 19, just tell me. I know I threw you into a hard one right away, but at least you have a clue because you know it's a negative. That means it's a rainbow. And 3a is going to be our maximum point. So I just want to know if you see 19 in our bingo game. I don't know if you had this in Algebra 2 maybe, or Algebra 1. Margot sees it good. I know I leapt into a hard one. I'm just trying to stretch your brain. So if math isn't your thing, this is your last math push. Like my son's the art teacher that Isabella had at Mellon. He only had to take 2 math classes at college. Oh, good. So Margot and Isabella see it. So let's see if Sophia sees it. It's hard because they don't give you this crazy formula. And I don't know why they put stuff on the test and they don't give you the formula. Like when we do circles this week, they don't give you the circle on the coordinate point. Thanks, Sophia, honey. Okay, so now we're going to do one more hard one. We're going to go to 1247, number 30. What is this lady thinking? So a pretty hard one, if you had a chance to get there. So we can see it's a happy day. It's a y equals x squared. Which of the following is an equivalent form of the equation from which I can get the vertex? So do you see it would be an A trap because that would just give us the intercepts. So we have to get the vertex form. And so the vertex form, do you see it would be D? Because the vertex right here at A, so it's a minimum this time. The vertex is 1 minus 16. So if I put that in the vertex formula, it would be 1 negative 16, which is answer choice D. So if you see 30, put a question mark if you honestly don't see it. They want to trap us. The key word in that problem is do we notice the vertex form? Oh, so Margot sees it, great. I don't know when, so does Isabella. Woo! I don't know when you had this in math class, actually. And then the axis of symmetry, Sophia sees it, is just minus b over 2a. So let's look. This is just a teaching page. There are many ways of solving quadratic equations. The graphing, it's difficult to use because you have to get the right window. It might be on the no calc section and you can't use the graphing calculator. Factoring, we did some like that. That's pretty easy. Taking the square root of both sides, completing the square. We're going to do a lot of that with the circle lesson. And then the big gun. So the only time you would need the big gun usually is at the end of the no calculator section. And there'll only be probably one problem, but they do not give you this formula. I don't know why. So we're going to try some using the quadratic formula. Okay, also, this part is known as the discriminant. This is sort of a review. When it's negative, there are no solutions because it never touches the x-axis. When it's 0, there's one solution. And when it's positive, there are going to be 2 solutions. And we're going to try some of those in a little bit. Okay, so this packet is almost done. Okay, so let's go to a book problem. I know this is a review of math. Let's go to 990, number 4. I'll give you time to get there. Which of the following is an example of a function whose graph in the x-plane has no x-intercepts? So it's going to be somewhere here. Do you see it would be C? No real zeros. So you're going to be up pretty soon, Jim. No real zeros. It's going to be flying up here. And that's pretty easy to see. Okay, so our example, we worked through a quadratic equation for you, but how about if we try one together, number 1. And like I said, you can have a great life and not solve this. So, But if I want to push you a bit, so A is 3, B is 12, C is 6. So we have our big gun that we're only going to need it one time probably on the whole test. So you could skip it if you'd like, but we have minus 12 b squared all over 12. Okay, so I'm going to work it down here for a second. So that'll be minus 12 over 12 plus or minus, this will be 72, so we'll get 72 over 12. Wait, 2a is 6. What was I thinking? I'm sorry. Okay, so this would be minus 2. I didn't make a mistake there. Sorry, guys. So this would be, remember our making marriages way. So we would have 3 2s, which is 8, and 2 3s. So I'm taking out a pair of 2s and a pair of 3s, which would come out as 6. So I would have minus 2 plus or minus 6 over a lonely square root of 2 over 6. So that would give us answer choice A. So could you do one of those on the test? You probably had the quadratic form sometime. Now I'm going to show you a trick, and this is a little hard to see, but stay with me, because this can save you a whole lot of confusion on test day. They often test you for the sum. And so we have to get both values and then add them. So let's try this one again. So A is 6, B is a minus 12, C is 4. So now we're going to do minus B plus or minus the square root of 144 minus 4 AC all over 12, 2A. Okay, so that's going to give us 12 plus or minus. Okay, so this is, yikes. This looks like a mess. It's going to actually be, this is what I want you to see here. The square root of 96 or something. But if I have the sum, now this is what I'm going to ask you if you see this. I will have 12 over 12 plus the mess. I know I shouldn't call it that, which is 1. 12 over 12 is 1 plus the mess, which is this. And then I'll have 1 minus the mess. I hope no math teachers are watching me do this. So then, do you see these will divide and I'll get 2 as my answer. So I didn't even have to solve all this because I just need the anchor number plus whatever's the radical, the anchor number minus the radical. Cross those off and my answer will be 2. Now nobody ever sees this the first time. So if you see the trick, put it in. If you don't, put a question mark. It's okay if you don't see it because it's hard to see. But I'm just trying to save you a lot of time on test day. It's just that we don't, when we have both solutions, we don't need to worry about this because there'll be a +1 and a -1. Oh, so Isabella sees it. Thank you, sweetheart. It's hard to see. Margot sees it. It's hard to see, but if you get the sum, then you know I don't have to go down that rabbit trail and solve all this. Oh, everybody sees it. Yay. Okay, so we're going to skip these. Let's go to number 4, though. Okay, on the next page, and like I said, most likely that people don't see that at first. So you could do the quadratic if they give you one in October. I mean, yeah. So we want 2 real solutions. So we want a graph where this value, and I'm just going to add the 3 to both sides, is going to be greater than 0. Remember, it's 1 if it's 0. It's no solution if it's negative. So let's solve this baby. So we have b squared minus 4ac, and we want it to be bigger than 0. So let's write our numbers down. A is k, b is 4, c is 3. So we'll have b squared 16 minus 4, k times 3 is bigger than 0. 16 minus 12k is bigger than 0. 16 is bigger than 12k. Divide both sides by 12. So, so k is going to be under 4/3, which is answer choice C. We're going to be doing another one like this, so not to worry. I just want you to, if they give you one like this, my goal on test day is you just skip through a lot of problems. Okay, so other quadratics. So a lot of other quadratics will be on the test for which you do not need the big gun. So like this one, I don't have to use any big quadratic. I know that the x plus 3, absolute value has to be 5. So x could be 2 or a -8. Thank you, College Board, for 10 points. I don't have to bring out any big gun. Okay, I want to get the x-intercepts. So no vertex formula. No vertex formula. I just need to, this will be x. What 2 numbers will give me an 8, x minus 2, and x minus 4. Not so bad. So you don't have to bring out the big quadratic formula, probably maybe one time. So let's try this one. I don't have to bring out the big gun. I just have a, let's see, plus 39, plus 2 numbers. Let's see, let me think. Plus 13. So a would be a -13, or a would be 3. 3 is the positive value. 3 plus 5 on this planet is 8. We did one like this the last class, and I just wanted to bring it up one more time. A is 2. Remember, we don't have to square both sides. We just have to try the choices. Well, 2 is going to give us 0, and that's not going to equal a -2. So 2 is out. Let's try 3 is going to give us 1 equals a minus 1, so 3 is out. So it better be 6. So, 6 minus 2, oops. So the square root of 4 is 2. That does work. And so that one would be D. And that's the fastest way. Don't square both sides and go into a rabbit trail. Okay, one a little bit different. Hopefully I haven't lost any of you. We want to get x plus y squared. So that's x plus y. So that's going to be x squared. Okay, pretty easy. X squared plus y squared is a. And then 2xy is, xy is a minus 10. So that'll be a plus 2a minus 20. Which is going to be 3a minus 20, which is D. Okay. One more of these guys. So a plus b squared on the top. So that'll be a squared plus 2ab plus b squared all over ab, which is 4. So this will be 2 times 4. So a squared minus plus b squared is 22. So we'll have 22 plus 8, because 2 4s. So that'll be 30 over 4. And you could use a calculator on this and get 7.5. So hopefully I'm not going too fast. We're almost done. How many real values? Okay, I know I test the discriminant. And I'm just going over stuff that's on the test. And I know it's probably been a while since you've had this. So this will be minus 12 squared minus 4 times 2 times 18. Well, that's 144 minus, hold on. Eight times 18, well, that's 144. So if it equals 0, there's only one place it touches. Thank you, College Board, for 10 points. Okay, so this one, I hope I'm not going too fast. One of you girls say too fast if I am going too fast. I'm trying to leave the work up. We're almost done. So I'm trying to get C here, but I have a point, minus 4 and 0. So I can put 0 in for y, minus 4 in for x, and so C would be a negative 24. Thank you, College Board, for 10 points. Okay, the last little thing is to look at the vertex form a little bit more. So if we're going to get the vertex form, you sort of see it has to be, this example, it has to be in D form. And we do all the work here, but let's go to question 1. Okay. We have this equation. So we know the parabola's like this because it's a negative day. And we know from the that 4, 6 will be our vertex. So this is a yes, this is a yes, and the axis of symmetry is yes. We don't know what the y-intercept is on this one. So I want to go to a really hard one. We're almost done with math. And again, I know this is a push. But if you can get points from this. So I want to turn to 878, number 30. And this was a brutal one, but I want to show you how it's not that hard. So it's the hardest one. And you might say, Mrs. Hessler, there's no way I can do this. So what we've got to do is get the graph for this baby, okay? So let's draw a line of best fit. So if we draw the line of best fit, we can sort of see, does everybody see we need the negative sign? So A and C are out. Because our parabola is like the rainbow. I'm not going to draw the rainbow again, even though I love it. Okay. So A and C are out, but let's look. We know the y-intercept, well, but my drawing is not perfect here. So we know the y-intercept is going to be about here. It has to be positive. And about, I don't know, where it would end, maybe 740-ish or something. So it can't, no, A and C are already out because they're positive. D is, hold on here. So D is a possibility. Hold on, let me see here. I can't see my book, hold on. So we know that it has to be a positive to begin with. So A and C are out. B can't be right because it has a negative 745. Do you see that? So B is out because we want a plus 74. So does anybody see that that one would be D? Even though it was hard, we sort of decoded it. So if you see 30, let me know. Because initially that might have been a problem you give up on because it's in the end zone. But if you draw the line and you just analyze it, you can see it's going to be like the umbrella. It's going to be negative, and then we're going to cross on the Y. So if you see 30, and if you don't see it, just put a question mark. Because you guys, I know you're catching so much of this. So Isabella sees it. If you have a question, I don't see why it's negative. I don't see why the y-intercept is 740. Just let me know. Oh, so Margot sees it. Thank you. So that was, we cracked the hardest one just by analyzing it. I love how you guys are so astute here. So Sophia out in Venetia, do you see this? Why it's a D? It might have looked intimidating at first, but when we drew the line of best fit, it doesn't have to be perfect. Oh, great, sweetheart. Okay, we're going to do this next one in the packet. We're almost done. I keep saying that, but okay, this one. The parabola that has a minimum value, so we know it looks like this. So it'll be x plus, wait, the formula is x minus h. So it's going to be x minus 2 squared minus 3, which would be c. And I'm just using the vertex formula. We're not going to try this one right now. I want to go into word problems. So if most word problems are going to be systems or slopes, but sometimes you could have a quadratic. So let's go to question 1. This isn't so bad. So the function d defined above models the distance in feet that a ball rolls down from an inclined plane in t seconds. So if it rolls 140 feet, that's our distance. Looks like a quadratic. You might have done these in physics. So I just divide by 1.4. So t squared is 100. Not so bad. T is 10. So I'm just saying you could get a quadratic. So let's look at this one. I'm going to do this all for you here so we can get to the grammar. The length is twice the width minus 8. And we know the area is 2880. So the width would be W. So I just multiply these. I would get then 2W squared minus 8W. And I'd solve the quadratic, which I'm not going to worry about right now because of the interest of time. So this would be 224. Let's go on. So another thing you could get is we're covering everything you could possibly see. You might get the intersection of a line and a parabola. So we did the example here. Let's try number 1. So if all of this equals x and this equals x, we can set these two together. Then it's not so bad. I just subtract the 2y. And I'm not bringing out the big gun, quadratic formula, no way. I'm just going to do y. 4 times 2 is 8. Why make my life hard? So y could be a 4, or y could be a minus 2. But I might be tempted to pick b, but I want the y to be 4 and minus 2, so I have to read it carefully. Okay, the last page, yay! Okay, so I have this parabola. So y is 4. and it's intersecting it at 2 places on the x-axis. What's the length of AB? So I just said this equal to this y. Take the square root of both sides. Wait, that's an x. Sorry, guys. So x could be a 10, or if we got the negative value, it could be a 6. And so the difference from 6 to 10 is 4. And this last one, I'm not going to do all the math. I'm just going to draw the line. So we have this line. We're going to start at -6, go up 2 over 1. Well, I get the point. It's at 4, 2, and 0 minus 6, which looks a lot like answer choice B. Yay, we conquered a really hard math packet, so you could show your mom and dad after this and say, woo! And I'm now going to give you the gym to do the grammar. I'll get that. You can just start. It's grammar 1. Hello, Chris Hessler. Hello. Yes. He doesn't live here anymore. Thank you.
Wait, I'm just gonna start.
Yeah. You gotta put it there.
Alright, hi everyone. So we're going to do our English lesson. I'm going to find the packet. It is grammar 1. See if I can find it here. And I'll monitor the chat room as we go. So this is our first grammar lesson. We're going to cover all of the grammar you will encounter on the SAT. But today we're going to focus on sentence fragments, run-ons, comma splices, subordination, and coordination, and we'll also talk about dangling participles. Okay. So this is grammar 1. So, sentence fragments. Not every cluster of words that you'll see on the SAT with punctuation is necessarily a sentence. It may be a fragment. And a fragment, unlike a sentence, does not express a complete thought. So by definition, a sentence expresses a complete thought, and it must contain a subject and a verb, and the verb must be in the right form. So the simplest sentence I could form would be something like this. Ooh. This is a sentence. Mike goes, period, is a sentence. So we have a subject. Subject's Mike. He's just the doer of the action. We have the verb, goes. The verb's in the right form. And the last thing we need is our punctuation. And we do have a period, so that is a sentence. But not everything that you'll see on the SAT is actually a sentence. You'll see a lot of sentence fragments. So here's an example of a fragment. Working all night long with no end in sight is not a sentence. There's no subject. I'll just make a note of that. No subject. It's kind of hard to write on this tablet. No subject. So who's doing the work? Let's fix it. Here would be a corrected version. Working all night long with no end in sight. Bill is exhausted. So now we have a subject. Now we know who's doing the work. So we have a sentence. So we're going to fix these 3 right here. And I think in the interest of time, we'll just do them together. All right, so the first example says the Nile, the world's largest river located in Africa. So this is a fragment. It's not a sentence as written because there is some problems. So we could fix it. I think we're missing a version of to be, this verb, in the second half of our sentence. So to fix this, I'm going to add a comma right here. So add a comma. The Nile, comma, the world's largest river, sorry, wrong place. The world's largest river, comma, is located in Africa. So there's my to be verb that I needed. The Nile, comma, the world's largest river, comma, is located in Africa. So we were just missing a version of to be, the to be verb, and is would work here. Let's do the next one. And don't worry about rewriting the whole sentence. You probably just have to change a word or two or move something around. I was pleased with the tomato soup that had been prepared, although not finishing the rest of my meal. So we are missing something in the second half of the sentence. I was pleased with the tomato soup that had been prepared. That's fine. But to fix the second half of our sentence, we would have to change it to although I did not finish. So it's kind of hard to write on this. I did not trying to fit the word finish in here. All right, I did not finish the rest of my meal. All right, so we have a main clause. I was pleased with the tomato soup that I prepared. We have a conjunction, a subordinating conjunction, although I did not finish the rest of my meal, so that's fine. Let's look at the last one here. When in 1814, Dolly Madison saved George Washington's portrait, making certain that it would not be burned by the British soldiers. Just a quick question for the chat room for number 3. We need to delete one word in order to make this a sentence. Which word should I delete? We just have an extra word here that is implying that more is to come. But if we remove a word from this sentence, we'll get if we remove a word from this fragment, we will get a sentence once we delete something. Just have to make a little change here. See if anyone can get this in the chat room. I know there's a little bit of a delay with the chat room. We just need to delete when. And I'm going to capitalize in. And that will fix it. So in 1814, Dolly Madison saved George Washington's portrait, making certain that it would not be burned by the British soldiers. Yeah, thanks, Margot. Yeah, there's a little bit of a latency. But you are correct. So the when just makes it seem like more is coming, and then our sentence just abruptly stops, which doesn't work. So sometimes you might need to delete something in order to make a sentence. Just remember that sentences express complete thoughts, and not everything that you see on the SAT will be a sentence. It's probably a fragment. It's probably a run-on. Run-ons have their own problems. So let's look at run-ons now. So, and we're going to introduce this idea of an independent clause. And an independent clause is really just anything that could be a sentence. It does express a complete thought, right? So, like a sentence, an independent clause expresses a complete thought. And I just sort of ask myself, could this be a sentence? Could this portion of a sentence be a sentence? If so, then it's an independent clause. And here's the issue. When we take two independent clauses and just smush them together without any kind of punctuation or without a conjunction, that's a run-on. So let's take a look at a run-on in action. They're all over the SAT. Here's a run-on. All right, I'm going to read it. Apollo 11 was the first manned space flight to the moon. Neil Armstrong, Buzz Aldrin, and Michael Collins made the pioneering mission. So hopefully you can realize that's two sentences in one, and you can't really do that. You can't join two independent clauses. You can't just smush them together like this, because we have two complete thoughts and they're joined incorrectly. So there are ways to join these correctly. We could make two different sentences. That would also work. Apollo 11 was the first manned space flight to the moon, period. Neil Armstrong, Buzz Aldrin, and Michael Collins made the pioneering mission, period. So you could make two different sentences, or you could join them using punctuation or a conjunction, but you just have to do it correctly. So a common impulse would be to throw a comma in. So many students say, well, you know, commas join things, right? What if I were just to stick a comma in here? Could I do that? And the answer is no, you cannot. This is what's called a comma splice. It is still a run-on. So it's still a run-on right here. Apollo 11 was the first manned spaceflight to the moon, comma, Neil Armstrong, Buzz Aldrin, and Michael Collins made the pioneering mission. So I like commas. Commas are great punctuation. Commas are relatively weak punctuation. A comma is not strong enough to do what we're trying to do here. A comma is not strong enough to join two independent clauses, two things that could each be sentences. We do have a piece of punctuation that we reserve specifically for this. We have a piece of punctuation that we use when we want to join two independent clauses, two things that could each be sentences that are related or contrast with one another. So quick question for the chat room. What punctuation works? It's not a comma. Which punctuation can you use for this example? Which punctuation joins two independent clauses? I know there's a latency. I know there's a latency with this. See if Sophia or Margot knows. We reserve a piece of punctuation specifically for this situation. And it is a semicolon. So semicolon to the rescue, we could put a semicolon right there. And it's perfect. It works. Apollo 11 was the first manned spaceflight to the moon, semicolon, Neil Armstrong, Buzz Aldrin, and Michael Collins made the pioneering mission. So this is the main use of the semicolon in English. We can join two independent clauses, two things that could each be sentences with it. They have to be related or contrast one another. I cannot say, for example, today is Saturday, semicolon, French toast is delicious, because those independent clauses have nothing to do with one another. So they have to be related or they have to contrast one another. But if they do, if your independent clauses are related or contrast one another, then you can join them with the semicolon, and it works just like this. They love semicolons on the SAT. Semicolons aren't every SAT. Yeah, not a colon in this situation. All right, so the next topic is coordination and subordination. So coordinating conjunctions join independent clauses to create what we call compound sentences. And a compound sentence is just a sentence made up of two or more independent clauses. And independent clauses are just anything that could be a sentence. That's an independent clause. So when so joined, these may be referred to as coordinate clauses, and these are the 7 coordinating conjunctions you should remember: and, but, for, nor, or, so, and yet. So these are the coordinating conjunctions, and I would prefer if you remembered these ones. They're the same ones down here in our chart here. Why would I prefer if you remembered if you memorized the coordinating conjunctions? Because there are only 7 of them versus the 30-ish. Oh, make that closed. Oh, looks like my software crashed. I gotta open up again. Sorry. Okay. So yeah. So I would prefer if you memorize these 7 coordinating conjunctions, because there's only 7 of them, versus the, I don't know, 30-ish subordinating conjunctions that are here in this chart. So you'll know, if it's not one of these 7, you'll know it's the other kind. That's why I would prefer if you memorize these ones. So what do? They just create compound sentences. So here's an example of it in action. Tomorrow may be a better option, but it's your choice. So here we have the coordinating conjunction but, and it's joining the second half of this to our first half, and we have a comma here. So tomorrow may be a better option, period, that's a sentence. But it's your choice, period. That's also a sentence. So that's how this works. We can use the coordinating conjunction but to join 2 things that could each be independent clauses. But we should now also introduce this idea of a dependent clause. So you will use a comma when you join 2 independent clauses with a coordinating conjunction. In this case, we're using this one. So you do use a comma in that situation. This will be the case whenever joining independent clauses with a coordinating conjunction. So we've talked about coordinating conjunctions and coordinate clauses. Let's talk about subordinating conjunctions, subordinate clauses. So these are a little bit different, but they're related to the same concept we just discussed. So we've talked about the independent clause, and I've just said it's just anything that could be a sentence. Well, a dependent clause is something that could not be a sentence by itself. Instead, it depends on a main clause. You may have learned this as a subordinate clause. It's the same thing. It's subordinate to a main clause, or depends on the main clause, however you want to think about it. So a subordinate would be someone who's lower than you at a job or wherever. You're subordinate. In this case, it's a subordinate clause. So it just depends on the main clause, or it is subordinate to, however you want to think about it. So every sentence must have a main clause, and that's just an independent clause, something that could be a sentence. The dependent clause cannot stand alone because it does not express a complete thought. So here's an example of a dependent clause, a subordinate clause following a main clause. So I missed an exit period. That is a sentence. That's something that does express a complete thought. That is an independent clause. That is a main clause. This is not a sentence. While I wasn't paying attention is not a sentence. So that is not an independent clause. That is not strong enough to stand by itself. Instead, it depends on the main clause. And here we're using a subordinating conjunction while. See if it's on our list. It is. We're using a subordinating conjunction while to join our dependent clause all the way over to our main clause. And the important thing to remember is that if we start with the main clause, there is no comma before your coordinating conjunction. However, if I start with the dependent clause, if I start with this for some reason, while I wasn't paying attention, comma, I missed an exit. So if you start with the dependent clause, you do need a comma. But if you start with the main clause, as you probably should, you do not need a comma in front of your subordinating conjunction while. So it's really just a comma rule. All of this for a comma rule, right? Basically remembering these 7 coordinating conjunctions, realizing that those are not any of these 30 or so subordinating conjunctions, and then you just realize, okay, did I need the comma? Do I not need the comma? So it's really just a comma rule. It just comes down to, are commas required? Are they unnecessary? So we're just going to do some of these together. And because math went over, I think we're just going to do them together just in the interest of time. Okay, bottlenose. Dolphins have more neck flexibility than other dolphins. 5 of their 7 neck vertebrae are not fused together. So right now we have a run-on. It is a run-on. It's a comma splice run-on. So even though our author put a comma right there, the comma is not strong enough to join 2 things that could each be sentences. We have 2 independent clauses. Bottlenose dolphins have more neck flexibility than other dolphins, period. That is a sentence. 5 of their 7 neck vertebrae are not fused together, period. That is a sentence. So we have 2 things that could each be sentences. I think that they're related enough to one another that I could put a semicolon right there. So that's one option. So a semicolon can join 2 independent clauses, 2 things that could each be sentences. We'll get to the colon in a minute. The colon is used slightly differently, but that would be one option. We could put a semicolon there. That would work. What's another way we could correct this? The other way I would probably fix this, I would probably eliminate this comma, and I would put in a subordinating conjunction because right there. This would work. So no comma. Bottlenose dolphins have more neck flexibility than other dolphins because 5 of their 7 neck vertebrae are not fused together. So because I started this sentence with the main clause, the one that could be a sentence, and I ended it with the dependent clause, the one that depends on the main clause. So because I organized my sentence in that way, there would be no comma before the word because. Now, if I started with the dependent clause, if I started with the second half of the sentence and I ended with this part, there would be a comma. I'll show you that. I'll just say it. I'll just read it. So here would be an example of starting with the dependent clause. Because 5 of their 7 neck vertebrae are not fused together, comma, bottlenose dolphins have more neck flexibility than other dolphins. So if you start with the dependent clause and you end with your main clause, you would have a comma, but typically you wouldn't do that. You should probably start with your main clause and end with your dependent clause. All right, so let's go to the next one. Pluto is no longer considered a planet. It has an orbit substantially different from the other planets in our solar system. This is another run-on. This is another comma splice run-on. It's the same idea. This is also a run-on. Pluto is no longer considered a planet, period. That's a sentence. It has an orbit substantially different from the other planets in our solar system, period. That could be a sentence. So I can't join two things that could each be sentences with a comma. That's still a comma splice run-on. That is, I am violating rules of English if I try this. So what could we do? Just like in the last sentence, I believe we could put a semicolon in here because these independent clauses are related so closely to one another. Pluto is no longer considered a planet, semicolon. It has an orbit substantially different from the other planets in our solar system. That would work. I could also do the same thing I did up here. I could grab this subordinating conjunction because, remove my comma, and put it right here. Pluto is no longer considered a planet because it has an orbit substantially different from the other planets in our solar system. So this is really just a comma rule. Do I need the comma? Can I not have the comma? What's going on with this sentence? Well, it really just depends on what type of clause you have, what type of conjunction you're using. Is it a subordinate clause? Is it a coordinating conjunction? What's going on? Once you figure that out, it becomes pretty easy. These are just grammar rules we're going over, but they're all over the SAT. So that's why we go over them, because they're on the test. All right, let's look at number 3. Just a few more here. I felt unprepared for the exam even though I studied. So here we have an independent clause. This is something that could be a sentence. I'm going to highlight it temporarily. I felt unprepared for the exam, period. That could be a sentence. This, however, is not a sentence. Even though I studied is not a sentence. I know that this is a dependent clause. How do I know that? I'm going to look at my chart. I think even though is on my chart, and it is. So this is a subordinating conjunction. So because I have our main clause, and then I end with my dependent clause, the thing that could not be a sentence in and of itself. So because I followed that order, I will remove this comma. I felt unprepared for the exam even though I studied, no comma. Now if these were reversed, if we started with the dependent clause, there would be a comma. It would say this, even though I studied, comma, I felt unprepared for the exam. So just be aware that if you start with the main clause and then you end with the dependent clause, if you end with the subordinate clause, there will be no comma. Last one, 4. The game was nearly over, yet the fans had not given up hope. Let's take a look at this word yet. Is this a subordinating conjunction or is this a coordinating conjunction? I'm going to check my handy dandy chart to find out. And it looks like it is a coordinating conjunction yet. So it's more powerful, it's stronger than the subordinating conjunction because it can create main clauses. Because it can create independent clauses, I should say. All right, here we go. So I looked that up. I saw that yet was a coordinating conjunction. I think I'm missing a comma. So we just have to figure out where it goes. The game was nearly over, comma, yet the fans had not given up hope. So this is a sentence, the game was nearly over, period. This is also a sentence, yet the fans had not given up hope, period. So I can join two independent clauses with a coordinating conjunction, yet I just can't forget the comma. Really, this is just a comma rule. So watch out for subordinating and coordinating conjunctions. Realize that you may need a comma or you may not need a comma depending on which one you have. Now we're getting to the colon. So the colon is used for slightly different reasons than the semicolon. It's used for a number of reasons. We're going to go over every reason you'll ever see a colon in English. So in sentences, colons are used to convey that whatever follows the colon describes, explains, proves, defines, or lists elements of what preceded it. That's all the colon is used for. And here's an important rule. I'm going to highlight this because it's such an important rule. An independent clause, something that could be a sentence, always goes in front of the colon. Now, what follows the colon is often a single word. There's no rule about what follows the colon. But an independent clause will always go in front of the colon. Something that could be a sentence must always go in front of the colon. Let's test it. I'm just going to test this one right here. Does this one work? My friends and I played a variety of sports yesterday, period. That is a sentence, so it's okay. It works. A complete thought, a complete thought, something that could be a sentence, must always go in front of the colon. But look what follows the colon. It's just a list of nouns. Hockey, basketball, soccer, and lacrosse. So that's not a sentence, and that's perfectly fine. It doesn't need to be a sentence. Sometimes it's just a single word that follows this colon. But whatever goes in front of the colon must be a sentence. Something that you could put a period on it, and it would be a sentence. It would be an independent clause. Lists are probably the main reason you'll see colons. It's just a list of sports. These are just nouns, a list of the sports that my friends and I played yesterday. We played a variety of sports yesterday, colon, hockey, basketball, soccer, and lacrosse. That's probably the main reason you'll see a colon, but we also use colons with descriptions. So here's a colon for the purpose of a description. A well-rounded education creates attentive citizens, colon, people who have the tools to analyze the information presented to them. So these attentive citizens, we're really just describing who these attentive citizens are, what they are, with this part that follows the colon. I'll just bracket it. This part just describes or describes, not, we're going to get to definition. That's another one. But this is just a description. We're describing what attentive citizens are with this information that follows the colon. Notice this. People who have the tools to analyze the information presented to them, that's not a sentence, that's not an independent clause, and that's fine. It doesn't need to be a sentence. However, everything that goes in front of this colon will be a sentence. A well-rounded education creates attentive citizens, period. So that is an independent clause. That is something that could be a sentence. An independent clause or something that could be a sentence will always precede a colon, but whatever follows the colon, it can be anything. Sometimes it's just a single word. We use colons when we have explanations. So here is a colon for the purpose of explaining something. The trip had been an ordeal. Well, why had the trip been an ordeal? Well, let's explain why. Well, we got lost several times on our way to the shore. So this sentence, it has an independent clause that precedes the colon, so that's great. It does not violate our rule, and that's correct. It doesn't even matter that this is also a sentence. We got lost several times on our way to the shore is a sentence, and it doesn't matter. It could be a sentence, it could not be a sentence. It doesn't need to be a sentence, it doesn't need to be an independent clause. It just can be. But whatever goes in front of the colon has to be, it must be an independent clause. And really, for shorthand's sake, I just often find myself saying, could this be a sentence? Could this not be a sentence? What I'm really saying is this an independent clause? Is this does this express a complete thought? And we use definitions with colons. So here is a colon for the purpose of defining a word, this word here. So we're just defining this word, this in quotation marks. I'm going to read the sentence. The word siamaki has particular interest for the psychologist. And here's just the dictionary definition. The act of fighting a shadow or imaginary enemy. So that's the final way we use colons. These are all the ways you'll ever see a colon used properly in English, right? And that was the last way you'll see it. You'll see it with dictionary definitions. And this is just this part here that I'm highlighting. This is just the dictionary definition of this word if I were to look this word up right now. So those are all the reasons you'll see a colon. They're slightly different than semicolons. The College Board also likes colons, so just be familiar with them. Be aware of all the different ways that they're used properly in English. Next, we're going to talk about dangling participles. So dangling participles and participial phrases, they're all over the SAT. The College Board loves these. They love dangling participles. So in order to understand what they are, let's first talk about what is a participle. Well, a participle is just a verbal. So it's similar to a verb. It fulfills a role like an adjective. So I'll try to give you an example. In English, there are present and past participles. Present participles would be these ing gerund forms, these verb forms. biking, dancing, swimming, hiking, riding, whatever. Any of these ing forms, these are all participles. These are present participles, just present tense verbs. But we also have past participles. Here are some past participles, past tense verbs. Written, spoken, and whispered. These are all past tense participles. So the interesting thing is these words, such as written, whispered, they can act as modifiers. So just as adjectives can act as modifiers in English, I could say, okay, the happy puppy. I can give puppy an attribute. I can call the puppy happy. That's an adjective. I can use happy to modify puppy. We can modify nouns with verbs. We can modify nouns with participles. So let's take a look at it in action just so you can see what I'm talking about. Here's an example. Mother opens the door wearing pajamas. So mother, of course, is our subject. She is just the doer of the action. Pretty easy to see that. She's opening a door. But we do have an issue. This sentence would be incorrect. Mother opens the door wearing pajamas. So right now, I have a participle, wearing. And right now, it's modifying the wrong thing. It's not, I need it to modify mother. I know that the mother is wearing pajamas, but that's not what the sentence says. This sentence says the door is wearing pajamas. The mother is not wearing the pajamas, the door is wearing the pajamas. And I know you may say, Mr. Hessler, of course I can infer that the mother is wearing pajamas, not the door. That's not what the sentence says. And it's just a proximity thing. This word door is much too close to this participle wearing. Mother needs to be closer. Mother needs to be where door is. Or wearing needs to be closer to mother for this to make any sense at all. So let's look at the corrected version. Mother, our subject. She's the doer of the action. And here's our participle. I'll highlight it. Wearing pajamas opens the door. So now our participle wearing is modifying mother. It's no longer modifying door. Now the sentence makes sense. Now the mother is wearing pajamas. Now the door isn't wearing pajamas. These are all over the SAT. We're going to see some examples in a second, but I just wanted to also mention that just like with a prepositional phrase, you can make participial phrases. So I'll just give you an example. A prepositional phrase, let's take a preposition. Here's our preposition. For is a preposition. I could take the preposition for, and I can add some words to it. For whom the bell tolls. That's all I did. I just made a phrase using this preposition for. You can do the same thing with a participle. You can take a participle, you can just add some words to it, and you get a participial phrase. So let's take a look at that. So here's our participle. I'll highlight it just as like I have been. Hoping is our participle, and all our author has done is added some words to this participle to make a participial phrase. This is the whole participial phrase right here. I'm going to highlight the whole thing maybe. Hoping to succeed in the interview. Now we have a participial phrase, and our participial phrase is still a modifier, but I don't think it's modifying the right thing in our sentence. Can hours of the day hope to succeed in a job interview? Of course not, but that's what this sentence is saying. As it's written right now, hours of the day, those hours on the clock, are hoping to succeed in a job interview, which makes no sense at all. I think we can agree John is the one preparing for this interview. John needs to be where long hours are. John needs to be right here. That's how this works. So it's not the long hours that are hoping to succeed in the interview, it's John. So here's a corrected version right here. Hoping to succeed in the interview, John spends many hours in preparation. So now John is doing the preparing, John is doing the hoping, not hours, and it makes more sense. It's just a proximity thing. Hours was close. It was too close to this participle hoping. That's all that was going on here. That also got rid of our passive voice. You notice that, right? Which is good. Passive voice should typically be avoided in your writing. Have your teachers mentioned this before? Passive versus active voice? I know. I'm just going to quickly say this. So, which sounds better? That's sentence one. That's sentence 2. So passive voice happens when objects are used as subjects. So here, ball isn't really supposed to be the subject. I can tell Matt is supposed to be the subject. This is why it sounds so strange when you say something like, ball is played by Matt. I just lost half my sentence. Sorry. Oh, ball is played by Matt. Okay, sorry. Ball is played by Matt. Okay, so it sounds crazy because you're using an object as a subject. The subject is the doer of the action. The subject is supposed to be Matt. So here he is in active voice. This is just the difference between passive voice. Passive voice, inactive voice. Active voice is typically preferred. And I just used passive voice to explain that active voice is typically preferred. Sorry. Use active voice. How about that? When possible. Matt plays ball sounds much better than ball is played by Matt. Because ball is an object, Matt is the subject. This has it backwards. All right, so let's look at this example. And again, because we're running out of time, I'm just going to do these for you, and you can just follow along in the chat room. Thoroughly lacking cohesion. Jake is not proud of his term paper. All right, I'm going to highlight the participle just as I've been doing for consistency. Lacking is our participle. So thoroughly lacking cohesion, Jake is not proud of his term paper. Well, if Jake thoroughly lacks cohesion, that means Jake is a puddle of goo on the ground. Jake has bigger problems than the term paper. Do you see why? I think this is why the College Board likes these. They're funny. They're humorous. So it's not Jake who is lacking cohesion, I hope. It's the term paper. Let's fix it. So let's say something like thoroughly lacking cohesion. Jake's term paper brings him no pride. Something like that would maybe work. All right, because it's not Jake that is thoroughly lacking cohesion. It's the paper. Thoroughly lacking cohesion, comma, Jake's term paper brings him no pride, brings him no joy, whatever. Written in stone, the Babylonian king Hammurabi included in his legal code the presumption of innocence. Okay, so here's our participle. I'm going to highlight it just like I've been doing. It's a past participle, but it's fine. It's still the same idea. So even though this is a past participle, it's still modifying the wrong thing. Can this Babylonian king be written in stone? Does that make any sense? Nope. So it's not the king who's written in stone. It's the code. So let's fix it. So written in stone, say code. The code of Hammurabi included within it. It's hard to write on this tablet. I apologize. Writing on glass is highly difficult, it turns out. It's not like a chalkboard. I don't know why. Written in stone, the code of Hammurabi included within it the notion of a, the notion of a presumption of innocence. All right, trust me, this is a sentence. I know I'll read it one more time just to make sure. Written in stone, comma, the code of Hammurabi included within it the notion of a presumption of innocence. So that would be a sentence that works. We've gotten rid of our dangling participle. In this case, it was a past participial phrase, but it's still dangling. It's still, when they say it's dangling, it's just modifying the wrong thing. Here's our last one, endangered. I'm going to highlight the participle. It's a present participle. This would mean that whatever follows is currently endangered right now. Endangered, the diminishing numbers of giant pandas caused Trina to feel concerned. And this is actually what's known as a double negative. So let me see if I can explain this concept in English. So you know how in math, if we multiply two negative numbers, you get a positive number. That's really plus 2. The same thing happens in English. What happens when the diminishing numbers of something are endangered. That would actually mean more pandas. Wrap your head around that one. If the diminishing numbers are endangered, that's a double negative. So diminishing numbers, they're already going down, are now endangered. That would mean they're going up now. Because diminishing numbers are going away. Is that weird? Yeah, if diminishing numbers are endangered, that would mean more pandas. So we have to fix this. It's not the diminishing numbers that we should be modifying. It's the pandas, right? So let's just fix it. We're not trying to modify their diminishing numbers. We're just trying to modify the pandas. Endangered. The giant pandas caused Trina to feel concerned. So now, it's not their diminishing numbers. Now the pandas are endangered, unfortunately. I think they're only threatened. I think this sentence is no longer correct, which is good. I think they've been upgraded from endangered to only threatened. So endangered, the giant pandas caused Trina to feel concerned. So they will test you on participles. This is our last thing. I know we're going slightly over time, but the math went ridiculously over time. That's the only reason why today. So just like before, even though normally I let you try these on your own, but we're running out of time, so I think we're just going to go through these 10 in order to get through the English a little bit faster, Margot and Sophia. So I apologize, because normally we like to introduce the concept and then let you attack some actual SAT questions, illustrating that concept, but just we're running out of time today. So I'll just go right into question 1. It's okay. It's not the end of the world. But these are all over the test, so we have to go over semicolons, colons. I can already sort of tell what's going on in this sentence, what they're testing on. So I'm just going to read the sentence to the left, and we will choose an answer choice for the right. A would be no change, leave the sentence as it is, it's great. And B, C, or D, those answer choices allow us to change the sentence in particular ways in order to make it work. So we'll read the sentence as written first. I'll read answer choice A, and then we'll decide if we want to change it. So here's A. At the heart of social media are conversations, those between friends, family, coworkers, and acquaintances. So we have a problem here. I think I'm missing some punctuation. But am I missing the semicolon or am I missing the colon? We have to determine which. And there's a real simple way to figure out is it C. There's a real simple test we can determine to see if a semicolon would fit, and that's this. If I put a semicolon right here, then whatever follows has to be a sentence. So this would have to be a sentence. Let's try the test. Does it work? Those between friends, family, coworkers, and acquaintances is not a sentence, so answer choice C is out. Immediately I can rule answer choice C out. There's only one other use for a semicolon in English, and it is so rare that I'm not even going to go over it. I've never seen it on the SAT. This is how you see semicolons in English. You frequently see them joining independent clauses. You very rarely ever see them the other way that they're used, to the point where I'm not even going to mention it because I've never seen it on the SAT. We can use a colon for the purpose of a description. Now I'm just describing what these conversations are. So I'm just going to throw a colon right in here. At the heart of social media are conversations, colon. Those between friends, family, coworkers, and acquaintances. So the part that follows the colon merely describes what these conversations are. So that is a colon for the purpose of a description, which we went over. Let's look at number 2. Merely liking or sharing a product or service on social media will not only spread to potentially hundreds of online contexts, and also carries with it a tacit endorsement that is hard to elicit from a public jaded by conventional advertising. So this is something we actually haven't gone over yet. This is what's called a coordinating conjunction, coordinate clause. What do I mean by that? Well, certain conjunctions go with one another. Either the conjunction either goes with or, the conjunction neither goes with nor. These are just coordinating conjunctions. Either goes with nor, neither goes with nor. Yeah, either goes with or, sorry. Maybe I'll write it out so you can see what I'm saying. Either. If we see the word either in a sentence, we should expect later on to see or, perhaps. and then neither or neither, however you want to say it, goes with nor, right? It's just a coordinating conjunction. And in this case, not only doesn't go with and also, it just doesn't. So hopefully you realize this. Not only can't, here's not only doesn't go with and also. It just doesn't. Instead in English, we say not only this, but also that, which is answer choice C. I'm going to read the corrected version with the corrected correlative conjunction. Merely liking or sharing a product or service on social media will not only spread it to potentially hundreds of online contacts, but also carries with it a tacit endorsement that is hard to elicit from a public jaded by conventional advertising. Here's number 3. Businesses today realizing the boost in sales social media marketing can produce, sometimes in a matter of seconds. So for question number 3, for this sentence, all I have to do is conjugate the verb to realize. Can you conjugate this verb to realize? Sure. Businesses today realize the boost in sales social media marketing can produce, sometimes in a matter of seconds. So that question was just testing you on conjugation. Can you conjugate a verb? Number 4, this relationship between a company and its online presence has generated a new field, semicolon, the social media manager. So I have a quick test. Oh, so yeah, we'll see you, Sophia. Sorry we went over time. Math went ridiculously over time. I'll only be 5 more minutes. But yeah, thanks for hanging around for as long as you could. Sorry for cutting into your dinner and everything. All right, let's just do, if Margot's still with me, we're just going to go over a few more and then we're signing off. I'm just going to do my quick test on this sentence. Can I put a semicolon here? Here's the test. Is this a sentence? The social media manager is not a sentence, so I cannot put a semicolon there. You just can't. I can, however, put a colon there because there is no such rule about the colon. Whatever goes in front of the colon must be a sentence. Let's make sure that works. I'm going to make this a colon. All right, whatever goes in front of the colon must be a sentence. Let's try it. Is this a sentence? This relationship between a company and its online presence has generated a new field, period. That is a sentence. We can use a semicolon right there. We're just explaining or describing what this new field is, the social media manager. Social media managers are at the forefront of an astounding new era, semicolon, redefining how we think about advertising. So I saw a semicolon. I'm immediately going to check, is this a sentence? Redefining how we think about advertising is not a sentence, so I cannot use a semicolon here. Answer choice A is out. I know we're really, beating this concept of semicolons to death, but they're all over the SAT. We're only doing that because they are on every SAT. For real. All right, so I can't use a semicolon here. And we haven't talked about this, but there is a rule that explains whether it's B or C. And this rule is called a restrictive clause versus a non-restrictive clause. And this is a restrictive clause. And if you haven't seen this before, we're going to do it in another grammar lesson, so I'm not really worried about it for today. But the relative pronoun that, when used in a restrictive clause, never takes a comma, which is answer choice C. So don't worry if you haven't seen this, we're going to go over it in another lesson. So social media managers are at the forefront of an astounding new era that redefines how we think about advertising. There's another comma rule about whether or not you need a comma. It just depends on whether you have a restrictive or non-restrictive clause. 6, social media managers asking themselves, which social media platforms cater to their company's chief demographics? So that doesn't work. We do have a conjugation issue, but we're also missing a helping verb. Social media managers must ask themselves which social media platforms cater to their company's chief demographics. So that conjugates our verb, asking correctly, to ask, and it also adds back in our helping verb, must, our modal verb. 7, demographics themselves can be bought and sold on social media. Children's toys are marketed to parents, the latest tech and games to teenagers, and retirement investments to seniors. So here I think we have a comma splice run on. I think we're joining two things that could each be sentences with a comma, which I said we cannot do. Demographics themselves can be bought and sold on social media, period. That is a sentence. Children's toys are marketed to parents, the latest tech and games to teenagers, and retirement investments to seniors. That is a sentence. We cannot join two things that could each be sentences with a comma. That's a big no-no in English. We can, however, use a semicolon. That is the main function of a semicolon in English. So we could put a semicolon in there. All right, let's go to 8. The best social media managers draw from many different fields simultaneously. They write copy, design graphics, curate videography and photography, analyze markets, and distribute marketing budgets. Again, we have a comma splice run on. It's the same issue we've been having over and over again. A comma is not strong enough to join two things that could each be sentences. But I could put a semicolon in here. The best social media managers draw from many different fields simultaneously, period. That could be a sentence. They write copy, design graphics, curate videography and photography, analyze markets, and distribute marketing budgets, period. That could be a sentence. So because I have two things that could each be sentences and they relate to one another or contrast one another, I can put a semicolon in there to join them. Number 9, utilizing their metrics. The proper course of action for a social media campaign can be determined by social media managers. So here is a participle utilizing. I believe it's modifying the wrong thing. Can the proper course of action utilize metrics? It's the proper course of action. It can't utilize anything. I hope you realize the only utilizers in our sentence would be the social media managers. Social media managers needs to be right where proper course of action is in order for the sentence to make any sense, because the social media people would be the utilizers. So I'm going to read the corrected version. Utilizing their metrics, social media managers can determine the proper course of action for a social media campaign. So watch out for dangling participles. Watch out for dangling participial phrases. They're all over the SAT. The College Board loves them. I think they like them because they're funny, I guess. I don't know. It's hard to make English funny. It's hard to make math funny. Let's look at 10. Here's our last one. An embarrassing social media post may go viral, semicolon, inside of quotation marks, tarnishing a well-established brand image almost instantaneously. So let's start out with what kind of punctuation in American Standard Written English goes within the quotation marks. And that would be commas. They live inside the quotation marks, as well as end of sentence punctuation. So periods, exclamation points, question marks, that sort of thing would also go inside of the quotation marks. Those things live inside the quotation marks. Colons, semicolons, they live outside of the quotation marks. So I already know A is out. It's in the wrong place. Another way I could know that A is out is I could just ask myself, is this a sentence? Tarnishing a well-established brand image almost instantaneously is not a sentence. So I can't join that to the other part of our sentence with a semicolon. Just can't do it. I can use a comma though. Because it's not a complete thought, I can join it to the rest of our sentence with a comma. An embarrassing social media post may go viral, comma, inside the quotation marks where it's supposed to go. Tarnishing a well-established brand image almost instantaneously. All right, so that is our last English question. This is our last question for this writing passage. So that is it. So Sophia had to bounce, but she was here 90% of the time. I'm really happy that she stayed after as late as she did. I'm sorry for keeping you late, Margot, if you're still here. I don't even know if you are, but I hope I didn't cut into your dinner. If not, you can just sign yourself off the way Sophia did. Thank you for sticking with me to get through the English. I know it was a little rough today, just because that polynomial lesson was so long, and that was, for the record, our most difficult math lesson, because that's about as hard as it gets on the SAT. They can't go much harder than quadratics and polynomials. So all we have to do for next time, we won't be meeting. You're actually going to take practice test 7 from the blue book and mail it to Mrs. Hessler. Sorry, mail it to Mrs. H. So if you do that, that's all you have to do. Thank you, Sophia. Thank you, Margot, for hanging out if you're here. Thank you, everyone, and we'll see you all next time. Please take practice test 7 when you're available, and just mail the bubble sheets to Mrs. Hessler whenever you get a chance. I'll sign us off, and thank you so much for being such a great group. We will see you all next time, and have a great day.